So I'm not really a technician, but with my understanding, there was the project in London, and the fire protection, for example, a study in London says that you have only 30 minutes for surviving in a burning building or you suffocate. And 90% of all victims in case of fire suffocate. And the reason is why, first of all, burns the furniture, the finishings, the carpets, and all this stuff. So I'm always going to ask me, what is really the big advantage of a non-combustible structure in concrete instead of wood? Because the structure is burning maybe after, I don't know, Wolfgang said 60, 90 minutes, something. Maybe, I didn't know. But the 30 minutes is more or less the critical time you get out and you survive in a building. Termites, yeah, you have chemical solutions, you have structural solution, constructional solution. So we did in Australia these 10 to 12 story high buildings, and so I think it's also makeable. Sound, yeah, we did a lot of testings, sound all over Europe, especially we in the KLH, we did this researching houses, and if we know the requirements, I think there are build-ups that you can fulfill all the requirements. Yeah, coming to the new technology, it's I think it's very, very important to have you as an architect, first of all, to develop projects and in this technology, and I think you are in the very, very beginning of this technology. And you know, the concrete is known over 100 years, and also the education on the university is almost based on concrete, and there is, you told me, maybe 0.1% of the education is wood. And that could be also an issue for the future to push this product. Yeah, advantages. I think you know it better than me, but I want to only to mention some advantages of building in wood. So the first of all, you are CO2 neutral, and that is, I think, it getting more important in the future. You are environmentally friendly. You're the predictable fire protection you have in wood. So you know the argument always is wood burns, and I say wood burns but controlled. So you have always, you can calculating and with covering with gypsum boards you get from 30 to 120 minutes of fire resistance. You have a fast and dry construction. You have free design options. You have the combination with other building materials. Yeah, that is a little bit the advantages. So, and now I want to show you the first multi-story buildings, because you know all over the world they will discuss about 20, 30 story high buildings in CLT technology. We are now in Vienna. There was starting the high-rise building of 24, I think, something 24 stories, and you also saw the curve of the development in Europe. Maybe that could be happen also in South America, especially in Brazil. So you can use it, the panels as for one family houses. So this is architectural designed house. You can use it for multi-story buildings, for terraced houses. So this cube architecture. You see this various claddings. You can do it in all kind of surface you want. You have the industrial buildings halls combined with the glulam. You have the residential buildings. You have office buildings, hotels. That is a very important market because you are very fast in the construction. You have bridges. You have towers, and not only observation towers. So 2012 we did 80-meter high tower for a windmill in Hanover. So the first project was in Vienna, so from 4, 5 and 6-story high buildings, and there is also one project in Sweden that we did, that was the first in massive wood of 6-story high. So the first was this building with 4 floors in Vienna, 112 flats, 7,500 square meter usable floor space. This is a low energy house, so the demand of heating that is not really a big issue for Brazil, but it could be also for the cooling. So we have to protect for heating, and you have to protect, for the other way around, for cooling. And so it's under 50 kilowatt per square meter and year. So this is the construction system, the structural system. So you have the outer walls, the bearing inner walls, you have the separating walls, you have balconies. They are always set before the construction. You also have a combination with the glulam. So you have, if you have the grate opens, you have always the solution with the glulam, so you can combine it. Then you have the build-ups, what normally is, so the separating wall, normally to fulfill the sound requirements is normally there is a gravel, then is isolation, and is a kind of concrete, and you have the suspended ceiling, so that is more or less the common build-up for in Europe for fulfill all fire and sound. So the net construction costs were comparing to the concrete. We had this prefabricated separating walls. So you see, for example, this first block was done less than a week. For erecting, you have here this prefabricating isolation. So there were everything there, the water, heating, electrician, and this shaft goes all over through this 4 floors. You see the shaft again. Then you have the protection for fire. This is prefabricated. And then it's finished, so you have the balconies in wood, and you have all the facade walls with isolation and cladding. That is, in the inside you have this open floor for entering into apartments. This is the finished apartment. So everything is in Europe is turnkey. So the floor and the ceiling and the walls are finished. So this was our next project. This was also in Vienna. It was the 70 apartments, and this was a standard passive house. So before we had this 50 kilowatt, and now we have below than 15 kilowatt per square meter and per year. And the erecting time was 14 months turnkey. And we had this prefabricated exterior walls. So that was prefabricated in the factory. So the windows were there, the isolation, and the gypsum board inside. That was also, that is a little bit different, the build-up, but more or less it's always still the same. So you have this sound protection, and this was measured always not in the laboratory, but always on site. That is the finished impression. So you always see here that the balconies is also in wood, and all the rest is clad in, and looks like normal building. That is Hyttkammaren in Sweden. So the big issue in Sweden is the sound, because the measurement is not done with 100 hertz, but it's 50 hertz. It's really deep frequency, and then you have not really a big advantage because the wood panels are very light, and therefore we did the prefabrication of these ceiling elements. This is a little bit on site, so you see again the erection. So this is these 8 apartments you will erect in more or less 1 week. The staircase is for fires always made in, or mostly in concrete. You have the separating wall, the inner walls, the ceilings, then you have the windows, and then you have these prefabricated balconies that is put on these steel elements. So they were also prefabricated. This is all these blocks was done in the KLH. So this is the finished. So you see here the wooden facade outside with the balconies and the very, very how to say, cheap roof construction with steel elements, so you can combine it in a very good way. Yeah, and then at the end some project got the architectural award. This is a kindergarten near Augsburg. You see here everything is in wood, inside and also outside. That is shingles of larch. This is another kindergarten, and with all glass facade and very, very open. You have also this really architectural designed one family house, so everything is protected, so the KLH is only, or CLT is inside, so only as used as a structure. Yeah, that is one family house in Corsica. So that was built up with the helicopter because there were no streets to bring these panels on site, and so everything was done by helicopter. Yeah. And hopefully it was a little bit interesting, and thank you for your attention.